Could we control extremely small machines thanks to the power of light? Today we take a look at two papers on nanomotors that got some interesting results. We will see the science behind and the potential applications. Now, the first paper, Plasmonic Linear Nanomotor Using Lateral Optical Forces, was published in 2020 in November by a research team from the Institute of Industrial Science at the University of Tokyo. And in this paper, the team presented their design of linear nanomotors. Linear, that is, motor that produces a force instead of a torque. And this motor can be moved in controlled directions thanks to light. Now, these nanorods, these nanomotors, are made of gold and silicon dioxide, and their size is around hundreds of nanometers. But how does it work? So basically this nanomotor movement is based on the orientation when it is exposed to a laser beam. These nanorods are designed in such a way that they allow constructive and destructive interference in one direction and in the other. Interference is a physical phenomenon of superimposition of waves, where the constructive interference is when the waves are in phase and the destructive interference is when they are out of phase. Basically, this interaction of constructive and destructive interference in two different directions generates directional scattering of light. And this causes the generation of optical force. So this optical force is generated and it moves the nanorods. And any force distribution can be potentially produced by designing in different ways the nanoparticles that comprise the nanorods. In addition to linear movement, it is in fact possible to produce also rotational movements. As we are seeing right now in this picture, the rods are arranged in a specific order in order to produce torque, and according to their distance you can increase or decrease the torque generated. The performance that can be achieved by these nanomotors is very small. Of course, we are talking about nanomotors, we are talking about extremely small motors, and it can produce about 900 femtonewtons. That is extremely small. I mean, femto is a prefix that is about 10 to the minus 15, so we're talking about 0 followed by 14 newtons. So it's extremely small, but it can propel these motors up to 7 micrometer per second. Now, a micrometer is a millionth of a meter, which of course, again, it's a very small performance, but again, we're talking about extremely small systems. And what is the advantage of this solution over other devices? Because this is not the first time that a nanomotor is moved by light. Well, the thing is that this solution does not need a focused laser beam, because the optical force, as we saw, it is generated thanks to the design of an nanorod and not based on the beam characteristics. And why focused beams are not very good as solution? Well, the thing is that they require specific motor sizes, specific materials and lenses. Not having the need of a focus beam means that you have more freedom in your applications. Regarding the second paper, Optical Matter Machines, Angular Momentum Conversion by Collective Modes in Optically Bound Nanoparticle Arrays. It was again published in 2020 in around October by a research team from the University of Chicago. In this paper, the motor is also powered by laser, but the physical principle that is used for locomotion is different. Basically, the idea is to use optical matter. This matter, these silver particles that are used, that are about 150 nanometers in size, they are held together by laser light, instead of being held together by chemical bonds, which is normal for normal matter, let's say, that is kept together by chemical bonds. Instead, these particles are held together by the light. And these particles are kept together by light because they are smaller than the light wavelength, and basically by the scattering of the light, they can self-assemble together into a structure that we're seeing right now in this picture. And the light that is incident to this particle is circularly polarized, and this circular polarization causes a counterclockwise movement of the particles, and it generates a torque. And the research team has devised several interlocking gears, thanks to these gears that they connect together, which allow the movement of various particles around. Now, we saw two solutions of nanomotors powered by light, but what are the applications of these nanomotors? Well, the applications are used in microfluidics. By microfluidics, we mean the design and the development of microsystems with pumps, valves and mixers, and they have several medical applications. Because these nanoparticles are way smaller than normal human cells, which are in the range of tens or hundreds of microns, while these nanorods are in the range of hundreds of nanometers, so we talk about a thousandth time smaller, and these nanoparticles can then potentially interact with the human body. It is also worth mentioning that these particles are usually realized in gold or in silver, so in materials that are chemically inert, so they're potentially safe. In terms of applications, we can see applications like sensing and location of potential pathogens and cancer cells, so they can sense them and they can also isolate them, they can capture these cancer cells. But as they can capture cancer cells, they can also deliver and capture specific drugs, specific substances to target cells, for example, drugs delivered to cancer cells. A third application is nanosurgery, so you can develop sharp nanomachines that can perform minimally invasive surgery, and finally we can also use these nanomachines for imaging. For example, they can transport molecules useful for ultrasound imaging or magnetic resonance imaging. So we can have a range of potential very interesting applications for these nanomachines. And the fact that these nanomachines, these nanomotors, can be powered by light is beneficial because it allows us more flexibility in developing medical solutions, because there are also other ways to propel these nanomotors. But using light could be helpful for safer applications. Now let me know your opinion in the comments about this very promising technology that I found extremely fascinating. If you like this video and you want to see more videos about these topics, let me know in the comments and put like, subscribe to my channel and hit the notification bell. Thank you for watching, my name is Paolo and see you next time.